Today I'm going to, hello everyone, I'm going to talk about like SQL plus vector. Okay. And large language models have revolutionized the way we solve problems, but they have severe limitations. One such limitation is due to the lack of training data, due to lack of data that are not part of the training set, leading to a phenomenon known as hallucination. This is also called the information limitation. While fine-tuning can adjust the behavior of large language models, the vector databases are like a key component to solve this information limitation. And that's why we are seeing like more people are using vector databases to build more and more powerful generative AI applications. So nowadays there are many like vector databases in the market, each falling into one of two categories. One is specialized vector database, such as Pinecone, offering performance. The other, like relational database, such as Postgres, offering convenience. This plus the user into a dilemma, that is a battle between convenience and performance. So imagine a user reliant on Postgres for storing its structured data, but also need to do vector search. He will find it like inconvenient to interface to databases, and often leading to increased complexity and often like potential data consistency issues when the data is large. So we have seen this many times in the past. And this is where like MyScale comes into play as a solution. Like MyScale allows users to run vector search with SQL. So eliminating the need to interface, to learn customized APIs and to interface the different types of databases. So you can use your familiar like joins-like syntax, run a nearest neighbor search, or in a simple like single SQL queries. But what's more important, I think, is this one. It is widely assumed that relational database cannot compete with specialized vector databases in terms of vector performance. For example, like Postgres with vector plugin has a huge performance disadvantage when compared with Pinecone. But MyScale demonstrates that with careful engineering and innovative algorithms, it is possible for relational database to match or even outperform specialized vector databases in terms of performance, sometimes by a factor of 5 or more, while retaining all the benefits of SQL. Let me give you two examples. One is customer from the financial industry. Like this customer wants to do analysis on structured and vector data. Like he has several constraints, like he wants to use like and join syntax to perform filter search, and want to support like various data types, like dates and strings, and also want to do self-query with LangChain. So given these complex constraints, usually like most specialized databases do not have the join support, and MyScale is the kind of like the best choice. In another example, the customer wants to build a research assistant that is to be able to build a chatbot that is able to chat with millions of papers so that the end user can ask questions about the papers, such as what is the promising material for room temperature superconductors, things like that. And because these millions of papers translates into hundreds of millions of vectors, so in this case, the cost is a key issue. And comparing is the best alternatives the user have tried, like MyScale reduce the cost by a factor of 3 and more, and reduce the latency also. So looking to the future, I think there's another point that I want to make here is that I think enterprises overpay for AI, despite its importance. If you look at the cost structure of building a chatbot, like 80 to 90% of that goes into the large language models. I think that that part can be reduced by a factor of 10,000. I mean, that's faster than consensus. Why so? Because in our applications, if you change that, if you host your own models instead of using commercialized APIs, that's a factor of 10. If you build advanced caching systems, that's another factor of 10. And there are many other techniques that you can use to reduce the cost, I mean, in addition to the hardware improvement. So I think there's a huge room for improvement, I mean, in terms of the language models. On the other hand, there is room for accuracy increase as well. I mean, we tested with like a base model. This is a chatbot problem. Like you have the base model, that is the Llama 2 with 13 billion parameters. And we use a vector plugin, that's a vectorized Wikipedia as a vector plugin, and the accuracy increases. But note that Wikipedia is already in the training set. though that this is the case, that the accuracy still increases. So if we, theoretically, you can prove that if you use larger vector data stores, then the accuracy will increase even further. But note that the cost of vector database is much, much lower than the large language models, using a large model. So it proves that using a medium to or small language model plus a large vector database can actually sometimes outperform the large language models, of a bigger size. So this obviously points out to a future way of a future direction. So in conclusion, I think there's MyScale allows users to run vector search with the SQL, and it proves that relational database can match and outperform the performance of specialized web databases while retaining all the benefits of SQL. And also, there's huge room for improvement. I think we also have a booth there, so I'm happy to chat more. Thank you.